So we dealt with the angle side case, and now what you see is angle side angle. So if you look, we have an angle, a side, and then an angle. What makes this one different is the side is in between the two angles. So that's what makes it angle side angle. Okay, so this is done very similarly. We do A over sine of angle A, which is 50 degrees, equals B, which is the 76. We know that's the B side because it's opposite angle B. So 76 over sine of B, which we don't know yet. And then we don't know angle or side C either, so side C over sine of 33.5. Well, if you notice, we don't have any fraction that's completely solved for right now. In the first fraction, we don't know side A. In the second fraction, we don't know angle B. In the third fraction, we don't know side C. So we have to go back and do the same thing we did last time. I'll just move that out of the way. Whoops. And solve for that third angle. So we know that triangles have to add up to 180 degrees. So let's just use the calculator for this one. We know this has to add up to 180, so we'll do 180 minus 33.5 minus 50, and that'll tell us that length of the third angle. So it's 96.5. So 96.5 makes the third angle for us. So we can replace angle B right here with 96.5 degrees. Now we can use B, or this fraction right here, with either one of the others to find those other sides. So we'll just do A first. If we go ahead and cross multiply, we get A times the sine of 96.5 degrees equals 76 times the sine of 50 degrees. And then to get A by itself, we divide both sides by sine of 96.5 degrees. Okay, so this is going to give us, gotta get a little more room, there we go, 76 times the sine of 50 degrees divided by, excuse me, the sine of 96.5 degrees. Make sure your calculator is in degree mode. So I end up, if I round, getting 58.60 for A. Okay, very good. Now, again, you could now replace the A with 58.60 and use these two together to solve for C. And that's okay, but it's really not best because you've rounded to get that 58.60. So it's best to use these two together to solve for that next part. So I'm going to change to blue so it looks a little different that way. Cross multiply and you get C times the sine of 96.5 degrees equals 76 times sine of 33.5 degrees. To get C by itself, divide both sides, by sine of 96.5. And we can do that portion in the calculator. 76 times sine of 33.5 divided by sine of 96.5. We get 42.22. 42.22. So now we know all the sides and all the angles of this equation. Or this triangle, rather. So we looked at two cases so far, the angle side, the angle side, the angle side angle, and the next one we're going to look at is a little tougher. It's called the ambiguous case. If you don't know what ambiguous means, it just means uncertain or unclear. And the ambiguous case is when you have side-side angle. I don't mean to be crass, but if you look at those letters backwards, it's not a really nice word. And this is not a really nice type of equation because it can be different things. So sometimes the information they'll give you cannot actually form a triangle. Why they would do that to you, I don't know. But sometimes the information you have won't actually create a legitimate triangle. Sometimes it creates exactly one triangle, or there are times where, given the information you have, two different triangles could be drawn. So let's examine this and see if we can figure out this particular one. We're going to look at one of each of those scenarios, but you won't know which is which until we solve it. So let me set up what we have. Side A is 55. I know it's side A because it's opposite angle A. Over sine 61 degrees equals side B, which we don't have any information on, over angle B, which we also don't have any information on. And then side C is 35. And then we don't know the angle C. So if you notice, in the other two we had two angles and we were able to immediately solve for the third angle. And the benefit of that is it gave us at least one piece of information for each fraction. Here, if you notice, A is completely solved, and that's great, but B's not. B's not solved at all. It has no information. We have no information about side B or angle B, and that's what creates this ambiguity, what makes it uncertain. Okay, so it doesn't help me to set this one equal to this one because I have little b and big B to solve for, so I'm not going to do that. I have to set the first and the last one equal to each other so that I can solve for angle C. So I do 55 times sine of C is equal to 35 times sine of 61 degrees. And notice this time I'm solving for sine of C. So now I'm going to divide both sides by 55 and get sine of C equals 35 times the sine of 61 degrees over 55. So let's pull up the calculator and see what that gives us. 35 times the sine of 61 degrees divided by 55. Okay, so I get 0.55657. Okay, so I'll write that here, 0.5565. Now if you remember, the way we solve for the C inside of the sine is by using arc sine. So we use arc sine, that's second sine, or sine to the negative 1, and then use the real number. So if you hit second and the negative, it just plugs in the answer for you. That way you're not approximating, you're using the real thing. And that gives us 33.82 degrees. So we get C is equal to 33.82 degrees. Okay, so it looks like this will work for at least one triangle. The question we have to ask is, will it work for two different triangles? And the way you figure that out is it turns out that sine actually has two values that will give you 0.5565. And the way you find the other is simply by doing 180 minus 33.82. Okay, and I'll show you what I'm talking about. So if we do 180 minus, and we'll just use the exact one here, we get 146.18. Well, if you take the sine of 146.18, you'll notice it gives you the exact same thing we had up above. So there's really two different angles that this would work for. However, we got 146.18. However, this won't work for our triangle, and here's why. If we were to plug 146.18 right here, we would have a problem. You have to remember, how many degrees should a triangle have? It should have 180. Well, if you add 146.18 plus 61 degrees, you're way over 180. So it's not possible in this triangle that that angle is 146.18. So we don't have to worry about that, and we just have exactly one triangle that this will form. So we will label that as 33.82 degrees. We can then figure out what the third side is by doing 180 minus those two. So 180 minus 61 degrees minus 33.82. And we get 85.18. Okay, so I can put in for angle B 85.18, and I know for angle C now that it's 33.82. So the last thing I need to do is solve for B. Here it's not super important which one you set it equal to because you've approximated for both, so it's not a big deal. I'm probably still going to use my original one right here just so we get into a good habit of doing that. So I'm going to do this in red. We get b times sine of 61 degrees equals 55 times sine of 85.18 degrees. Then divide both sides by sine of 61. And we'll see what we get. 55 times sine of 85.18 divided by sine of 61. Don't forget, you've got to close that parenthesis, so I need to go back here and put a parenthesis in there. Alright, there we go. We get 62.66. So the length of side B is 62.66. So we now know all the pieces of this triangle.